Now that we've learned all kinds of things about waves, we're going to investigate waves in a piece of equipment called a ripple tank. We're going to study reflection, refraction, diffraction, and interference. So let's investigate the wave phenomenon of reflection in a ripple tank. So here's my ripple tank, this big blue area here, that's all water. And in the ripple tank we've put this barrier or boundary. So we're going to have waves that are going to come down and hit this boundary, and we're going to see what they do and learn about the principle of reflection. So let's do it. So here come the waves, and they bounce off the boundary just like that. But now let's look at this a little more carefully. And the way we're going to do this is so we can make some measurements. We're going to draw a reference line, which is called a normal. And we're going to put the reference line right here. The reason we call it a normal is this line is perpendicular to the barrier. So that's going to be our line that we use to represent the waves, that represent the reflection, and to make measurements. So let's let the waves advance here a little more. And we want to represent these waves, so that here's the waves all coming in, with one line. We're going to use one arrow. And we're going to draw it like this. And this arrow is going to represent the waves coming in, which are called the incident waves. And we're going to let them reflect. Now you can see them reflect off the barrier, and notice here's the waves that have reflected. And what we want to do is compare the direction of the waves that have come in, which are the incident waves, and with the direction of the waves that have reflected. So let's get another arrow, and this arrow is going to represent the direction that the waves have bounced off of the barrier. And you'll notice that I have waves coming in at a certain angle. So I'm going to say here are the incident waves, and they make this angle with the normal. So I'm actually going to measure that angle, and I would call that angle theta I for the incident angle. It's the angle that the waves come into the barrier with. And I also notice that the reflected waves also make an angle with respect to the normal. I make all my measurements with respect to the normal. And so this angle is called theta R for the reflected angle. And if I notice, it seems very much that the incident angle of incidence, equals the angle of reflection. So let's watch. And we'll watch the waves come in one more time, the incident waves, and they bounce off the barrier, and I see the reflected waves, and I see that the angle of incidence equals the angle of reflection. And now I can also let me first of all get rid of all of this. I can also see this in 3D, which is maybe the coolest way to view reflection. So here come the incident waves, and they bounce off. And so the angle of incidence, or the direction that the incident waves come in, and the angle that the reflected waves come off, that's equal. Angle of incidence equals angle of reflection is called the law of reflection. The next wave phenomena in a ripple tank that we're going to talk about is called refraction. Now in refraction what you end up having is two different media. So that would be like the deep end in the ripple tank, and this would be like a shallow end. And the bottom line is waves travel faster in a deep end than they do in a shallow end. So we're going to see what happens when waves pass from a medium where they go fast to a medium where they go slow. So let's watch and see what happens. Now, first of all, notice that two things happen. So here's thing number one. Thing number one is you get a wave that bounces off this boundary. So when the wave got to this boundary, some of the wave energy actually bounced off of it. And then you have thing two, which is some of the wave energy, when it got to the boundary, actually passed into the new medium. But look, it's not the same, along the same line. It's not the same shape. So let's continue on and see what there is to see. Now I'm noticing that the direction of this wave is actually bent. So when it goes from the faster medium, deep end, to the shallow end, the direction of the wave is bent. It's almost like the wave wants to be straight, but this end of the wave over here got slowed down. So it got bent kind of behind the original direction of the wave. So when a wave goes from a fast medium into a slow medium, the wave is bent, and that bending is called refraction. Now what we're going to do is also view this at a higher frequency so we can maybe see a little more carefully what happens. So we turn up the frequency and let's run it again. Notice a higher frequency, waves are closer together. And now notice, here's the waves that are coming in, but when they go into the shallow end, when they're slowed down, these waves bend. So that bending is called refraction. Now to look at this a little more carefully, let's do this. Let's choose to put our normal back in. And the normal is our reference line that we can use to make measurements. And let's let waves be represented by an arrow again. So we're going to use this arrow to represent the waves that are coming in to hit the boundary. And then we're also going to use these waves. Look at these waves in the shallow end, the slow end, and we can pretty clearly see with these arrows that the waves have changed direction, so that these waves have refracted or bent, which occurs whenever there is a change in speed, when waves go from one medium to another and there has been a change in speed. We can characterize this bending by referring to this normal line. So what we would say is that when waves travel from fast to slow, they bend towards the normal. When the wave bends from fast, goes from fast to slow, it bends down towards the normal. Let's define what refraction is, and then we'll see what it looks like in an actual real ripple tank. Refraction is the change in direction of a wave as it crosses the boundary between two media in which the wave travels at different speeds. When waves go from fast, which occurs in deeper water, to slow, which happens in shallower water, they bend towards the normal, as we've just seen. Let's see what refraction looks like in an actual ripple tank. Here, what looks like white is actually the deep end, where the waves are going to be traveling fast, and the yellow area is actually a plastic piece that's been placed in the water to make a shallow end. So the waves are going to go from the bottom where they're going fast into over the yellow where they're going to go slow. So let's watch and see what happens. Now notice the waves traveling in the deep end are maybe going something like this. And once they get to the shallow end, they're going something like that. So it looks like the waves, if I look at the direction, are traveling like this, and then they bend, traveling that way in the shallow end. And that bending is called refraction. Now here we can see it from a different angle, and I think you can see here that here's a wave that's going like this and then it bends that way. And here's a wave that's going like this and it bends that way. And here's a wave that's bent. So that we can see when the wave goes from the deep end, this is the deep end right here, to the shallow end, the direction of the waves changes, and that direction change is called refraction.